Hi, if you're watching this video, you must want help on 5.2 Check on Learning. So let's get started. Of course, I lost my pencil. Well, anyway, I don't need it for this first one. I found it. Explain how you can use the number of zeros of a polynomial function and their multiplicities to determine the degree of polynomial function. So select the words in the drop-down menu. This is basically just kind of making sure you were kind of sort of paying attention. So the multiplicity of zeros to identify the degree of a function, you are going to add the multiplicity of zeros to identify the degree of a function. For example, a polynomial function with two zeros, each with a multiplicity of 2, so again, that's two zeros, each one has two multiplicities. So 2 plus 2 is 4. There you go. Easy enough, right? Here's where it becomes fun. So we've got find all zeros of the function p of x. So at this point, especially because it's an x cubed, I have no idea kind of what direction to take us in with that function. So I'm going to pull out my handy dandy graphing calculator. Now, I'm going to warn you, you can use this to help guide your direction. I still want to see the math. You still have to see the math. You can't just plug this stuff in and then give me an answer. But graphing this will actually help us, that didn't work, will actually help us figure out what direction to go so we're not spending our time just plugging and chugging and not getting anywhere. So notice how when I copied and pasted, it did not transfer the exponents over. And I knew that right away because I was looking at a line as opposed to a curve. So when we were talking about all those characteristics of graphs, that's why. So you can, when you plug stuff in, you know if it makes sense or not. So this graph here makes sense. And you can see that it crosses the x-axis 3 times. So this time, that's at x equals negative 10. I'm going to go ahead and write that down at x equals negative 10. We're going to turn off those annotation stuff. So that's probably going to be important. So that's a real rational root that will be able to work. But if you look at these other two, that's going to be a decimal point. So that is what we're going to call an irrational root. So we've got one here and we've got one there. So that's all going to be a little bit more, I don't even want to say a little bit more challenging to find, but that's what this lesson is about, is finding these roots. So, but this gives us somewhere to start. So we go back over, we know that x equals negative 10 is a 0. So I'm going to write that x equals negative 10 over here so I can get rid of it there. So if we divide that or use our synthetic division, we can figure out what we have left. So just setting up my synthetic division with my coefficients 1, 8, negative 24, negative 40. And we're going to use negative 10. So 1 comes down, 1 times negative 10 is negative 10. It's going to be negative 2. Negative 2 times negative 10 is 20. So we're going to have negative 4. Negative 4 times negative 10 is 40, plus negative 40 is 0. So that was expected, but this kind of proves that this is a root. So remember, it is x plus 10. So again, why is it x plus 10? Because when we take this negative 10, shove it in there, it needs to equal 0. That's the whole point of this. So just make sure you guys get your negative signs correct. So then we can finish this out. So we've got x squared minus 2x minus 4. So I'm thinking to myself, can that factor easily? And it definitely can't. And I'm going to pull up our hints. Oh, don't need a periodic table. Okay, so now we're looking to see if this matches any of these. So so there's a 4 squared, or 2 squared. So these are both squares. It's close to a perfect square trinomial. I wonder... How would we factor that? Is it not factorable? That would be a shame. Well, I can't figure it out. So what we're going to have to do is use the quadratic formula. I guess it'll work. It'll give us what we need to do. So here we go. So as a reminder, our quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So we are going to plug that in. So we're going to have a negative 2 plus or minus square root negative 2 squared minus 4 times a, which is 1. Go away security message. And c, which is negative 4, all over 2, because a is 1. So that's going to equal a positive 2 plus or minus square root, so that's going to be 4 minus plus, there's a minus sign and a minus sign. 4 times 4 is 16, all over 2. So that's going to be 2 plus or minus square root of 20, all over 2. Square root of 20 is the same as the square root of 4 times the square root of 5. So we can rewrite this as 2 plus or minus 2 square root of 5. So again, that just turns into a 2. All over 2. All of our 2's cancel out, so now we have 1 plus or minus square root of 5. So here's our answer. We're going to get rid of the rest of the stuff. So our final answer is going to be x equals a negative 10, a 1 plus square root of 5, and a 1 minus square root of 5. So I'm going to go check that answer, make sure it's right, and I'll be right back. Hey, so I just looked at the answers. Here they are. which is exactly what we had, so good job. So we're going to move on to question 3. So in question 3, find the polynomial function that has an integer coefficient. With the given zeros, we're going to be doing the exact opposite. So we have the zeros, now we need to find the polynomial function. So here we go. First one's easy, quote unquote. So it's 2, so x minus 2. Remember, when we plug 2 into that, it should equal 0. Next one is 3 minus square root of 7. So again, we're not doing anything weird just yet. But since it is a rational or an irrational number, we also need to multiply by the reciprocal. So in this case, it is going to be x minus 3 plus square root of 7. So here are the answers that we can check, and you will notice that, bam, we got it. So we are good to go there. So let's go back and let's start number 3. So number 3 says find the polynomial function that has the integer coefficients, a leading coefficient of 1, and the least degree for the given zeros 2 and 3 minus square root of 7. So start off, so these are our zeros. So our first one is, kind of what we're used to, x minus 2. So again, why is it minus 2, not plus 2? When this positive number gets put into this x, that needs to be equal to 0. So now we have 3 minus square root of 7 to deal with. So if we treat that as a number, then we would continue as we were kind of doing. So x minus 3 minus square root of 7. So our parentheses are starting to get a little confusing, so I'm just going to color code some of them. But we also learned that anytime we have an irrational square root or an imaginary number, the reciprocal is also a root. So we need to include the reciprocal of this, which is just 3 plus square root of 7. So that would be x minus 3 plus square root of 7. And now we start mathing. So let's get rid of this stuff and we'll switch to black. So I'm going to start with, I'm going to start with this just right there by itself because I have a feeling that some of that's going to cancel out. And that's what I'm looking forward to. Get the mouse out of the way. So we'll start with our x. So we've got x times x is x squared. So then this x times all of this. So that is going to be, but remember it's a negative. So let's go ahead and distribute that negative in. Okay. So x times a negative 3, negative 3x, x times a negative square root of 7, that's minus x square root of 7. So I did switch those around, but when you're doing products, that's okay. And Okay, that's it. So now I'm going to distribute this negative sign. So now the negative 3 gets times by that second part. So we've got negative 3x, a positive 9, because negative 3 times negative 3, and a negative 3 times a negative square root of 7 is going to be plus 3 square root of 7. So at this point, we're just going to leave it like that. So now we have to do our square root of 7. So our square root of 7 times x is going to be a positive x square root of 7. Square root of 7 times negative 3 minus 3 square root of 7. Square root of 7 times a negative square root of 7 is going to be a minus 7. So that is all from just those two. But if we look at them, let's start color coding. Negative x square root of 7, positive x square root of 7. Goodbye. 3 square root of 7, negative 3 square root of 7. Goodbye. And the rest of that is not terrible to deal with. So what we have left over, and I'm just going to go ahead and bring our x minus 2 down. But what we have left over, x squared minus 6x 789 plus 2. Okay? So now we have to put our x minus 2 into the whole thing, and then we'll be ready to go. So we'll start with our x. It's going to be x cubed minus 6x squared plus 2x minus 2x squared plus 12x minus 4. So then we combine like terms. X cubed is still there. We have a minus 8x squared plus a 14x minus 4. And it says enter the correct expression in the box. So this would be our answer. So let's double check that. X cubed minus 8x squared. Woo! So you would type this into that box. So again, just to recap a little bit, when you have an irrational square root, you also have to include the reciprocal of that square root. And double check your negative signs, because I can't tell you how many times I had to do this problem before I got the right answer. And it was just the negative signs that was messing me up every single time. So good luck. Let's go to number 4. So find the polynomial function that has the integer coefficients, a leading coefficient of 1, and the least degree for the given zeros, -1, 2, and -I. So these first two numbers shouldn't be terrible. So we've got x plus 1. Mr. Lin, why is that x plus 1? Because when we add, or when we substitute the -1 in, it should equal 0. Thank you, Mr. Lin. So then we've got 2x minus 2. So there's 2 of our roots. And then we've got a -I. So we can just do x plus I, but we also have to include the reciprocal. So in this case, it would be x minus I. So what is actually happening there? If you remember, all complex numbers is in the form of a plus bi, where a and b are real numbers. So the reciprocal of this is a minus bi, but in this case, that I is really 0 minus 1i. So we did the exact same thing that we did with the irrational square roots, but since that 0 wasn't there, we just have the reciprocal of this is 0 plus I, so that's why we just have a plus and a minus. So don't get confused by that. These two things right here could easily be written as x minus parenthesis 0 minus I, and then the reciprocal of that would be x minus 0 plus I. Okay, so this part right here messed me up at least 3 or 4 times doing these problems. So I want to make sure that you guys don't make the same mistakes I do. And then you can, again, double check me. We distribute the negative sign in through there. So then we get x plus I. And then we distribute the negative sign through there, x minus I. So I want you to know that this part is happening because it is the same process for both imaginary and irrational functions. Okay, let's continue. So there we've got that. We're going to start with these two because, again, we're hoping that a bunch of them cancel out, and we've got i's, so that will be whenever you square them, they'll turn into -1. So let's do that. So we've got x squared, x times x squared, minus ix. So then we're going to our i's plus x plus ix minus I squared. So hey, look. Oh wait, let's use new fun colors. So we've got a negative ix and a positive ix. Bam, gone. We also have a negative I squared. Remember, I squared equals -1. So we have x squared plus 1. So that's not bad. So then we add our other factors down here. X plus 1, x minus 2. We can go either way you want. I'm just going to take this, put it into there. So it's going to be x cubed plus x squared plus 1. X minus 2 is still left over, so then we're going to do the x minus 2 in there. Combine like term. Okay, we're fine. So x to the 4th plus x squared plus x cubed plus x. Well, I'll make that look nice. X. So now we're going to do our -2 2x cubed minus 2x minus 2x squared minus 2. So now we're going to combine like terms. We've got cubes I see squared, squared, and then x, negative 2x, and then there we go. So we've got x to the fourth minus x cubed plus 2x squared nope, that's wrong. So we have a negative 2x squared, we have a positive x squared, so that's going to be a minus x squared. We have a negative 2x and an x, so it's going to be minus x minus 2. So that should be my answer. Let's check it. Look at that, there it is. Isn't that a beautiful sight when you get an answer right? So there you go. So again, this is number 4, and the answer is circled on the screen. So we got 1 left. We can do it. I have faith in us. So Mara created 2 different how-to videos, hopefully they're not about math, and created a model L for each video to represent how many likes she gets each day. D days after releasing the videos. So she had a birdhouse video, we're going to call LB, which there's your function. We had a planter video, LP, which there's your function right there. Using a graphing calculator to find how many days after releasing the videos the number of likes is approximately the same. Enter the correct value in the box. So we want to figure out when these functions are equal. So we can either set them equal to each other, or we can just automatically subtract one of them from the other. Doesn't necessarily matter which one we do for which one, from which one, but so that's what we're going to do. So we're just going to take the top, subtract the bottom. So we're just going to change all the signs. And then I pulled out my handy dandy calculator where the screen is going dead. 490.44 minus 222.6. So we've got 237.84. So I am moving backwards, just so you're tracking. 5.12 minus 25.6 negative 20.48D. So now I'm on the D squared. Got a negative 0.16 plus 6.8. So let's see, that's going to be a D squared, and we've got a positive 6.64, and then 0.08 minus 0.4. So this is going to be a D to the third, and that's going to be 0.32 with the negative type. So now from that, we're just going to plug that into our calculator. So I don't know if you can see mine or not, but again, you're just going to use this button right here, y equals, plug that in, and then use the graph. I'm going to use this thing right here because it's easier to see. So let me get rid of all these stray little marks. And here we go. So negative 0.32. And this calculator requires me to put my letters back into X. Yours probably does too. 6.64 X power of 2 minus 20.48 X plus 237.84. Not even on the screen. So we're going to zoom out. So there's some stuff up here. So these would indicate that there are some imaginary zeros. But since we're dealing with the real world, we only care about this one. So remember, when this 0 hits, that is when her likes or whatever are the same. Releasing the videos, the numbers of likes is approximately the same, yeah. So we just need to know what this number is right here. And it's going to be 19.425. You can do that on your calculator. I think there's a way that you can find your x-intercepts. If not, you can always use the table function and then just shove x equals 0 into it, and then you should be able to get some answers. So I can show you how to do that on your calculators in class. It's a little bit harder to do here on a video. So we're going to take 19.425, 19.425, and we're going to see if that is our answer. They got 18. This is the number that I went wrong at. Apparently I don't know how to work a calculator. Don't mind me. But luckily, since it's already set in there, I don't have to change much. So 17.699, so that makes a lot more sense given that what their answer is. What number did I say? 17.699, which then rounds to 18. So we're going to use 18 because they're talking about a whole number of days after. So there you go. Check on learning. Consider it checked. I'll see you in class.